In this video, we're going to be talking about Network Address Translation, or NAT for short. We're going to be looking at the problem, so why NAT is needed. We're going to be looking at the solution, so why NAT helps to solve that problem. And we're going to be looking at the three different types of NAT. Private addresses. Bet you thought I was going to say NAT then. No, private addresses were developed to help prolong the life of IP version 4. What these people did was create three groups of addresses and called them private addresses. These addresses can be used over and over again. So what we're left with is a small group of addresses that can be used billions of times, trillions even, over and over and over again. There is one slight catch though. These addresses can only be used inside an internal network. They are not allowed over the public internet. Let's see an example. Let's say this is your home. Here is your computer, here is your printer, and here is your tablet. They're all assigned a private address from the 192.168.0.0 group. This works fine communicating with each other. They get along pretty happily. But if these addresses can't access the public internet, does that mean they can't do anything outside of their internal network? Let's add a router into the equation. When you sign up with an ISP, they will give you a public address. This can be used on the internet, but usually they only give you one. So with all these devices, how can we use just one public address? This is where NAT comes into play. NAT converts private addresses to public addresses. Let's take a closer look at how this works. We will simplify this to make it easier to understand. First, we'll look at PAT, which stands for Port Address Translation, also known as overload. This is by far the most popular version of NAT, and is what you'll be using in your home. When your computer sends data to the router takes a look at it. It looks at the source address, the port number, the destination address, and the destination port number. Now the port number is very important here. Not only will it distinguish which device the data belongs to, but it also tells the device which application that data belongs to. Very simply, the router swaps out the private source address and port number, then swaps it for a public address and port number. The port number will often stay the same, but if it's already being used, then the next available one will be selected. To keep track of which public addresses belong to which private addresses, the router builds a NAT table. This table matches the private address and port number to the public address and port number. Once the router swaps the addresses and adds it to the table, it rebuilds the data and sends it on its way. When the data comes back, the router again looks at the addresses. The source address is now the address where it came from. Some web server somewhere doesn't really matter. The destination is now the public address and port number. The router looks at this and checks the destination against the NAT table. If it finds a match, the router will swap out the public address and port number for the private address and port number. It will then send it on its way. Once the computer has the data, the port number will tell which application to send it to. If you're searching the internet, for example, it can even tell which tab to send that data to. Dynamic NAT. Dynamic NAT actually goes against everything I've just said. It doesn't save addresses because it's a one-to-one mapping of addresses, but it's still a type of NAT nonetheless. For dynamic NAT, you need to manually create a pool of public addresses. This would require you to purchase these public addresses from your ISP. Our pool will be represented by this bucket, because I didn't really know how to draw a pool. Apart from that, dynamic NAT works in pretty much the same way. When data comes in, the router looks at the source and destination address, swaps out the source address for the first available public address from that pool. and then it sends it on its way. When the data comes back, it again looks at the source address, then looks at the destination address. If it finds a match in the NAT table from the destination address, it swaps it out for the private, and then sends it on its way. After this is done, the public address will return to the pool, ready to be used again. Lastly, we take a look at static NAT. Static NAT requires you to manually type in the entries to the NAT table. You tell the router which private address and port number translate to which public address and port number. Once this is done, it works just like the other two versions. When the data comes in, it checks the NAT table for the source address. When it finds a match, it swaps the address for the public address, and then sends it on its way. When the data comes back, it checks the destination address against the NAT table, swaps the public for the private address, and again sends it on its way. This version of NAT is mostly used for public servers like web servers, for example, where the port will always be 80, for example, for HTTP. So, NAT translates private addresses to public addresses. It does this by using a NAT table to keep a record of these translations. Very clever, but pretty simple. If you enjoyed this video, and we hope you did, please give us a thumbs up, comment, and subscribe. These videos are for you. So if you want more, let us know. That's it for network address translation. Thank you for watching.